Okay. So this is the questions that I gave you. Okay, so let's look at the first question. We have three diagrams, okay, with different forces exerted onto an object. So let's look at 1A. So can I call IV? IV go. Can you please tell us what is the resultant force for A1, 1A?
Newton.
Okay, so resultant force for 1A is 10 Newton. So what about the others? Do you agree that the resultant force for 1A is 10 Newton?
20 Newton.
20 Newton. So which one do you think is more accurate? 10 Newton or 20 Newton?
Because it's same direction.
Okay, so because of the forces exerted onto an object M are in same direction. Okay, so if we write the calculation here, okay, resultant R equals to the first force plus the second force. Okay, so the first force, let's take 5 Newton as the first force plus 15 Newton as the second force, and both forces are in same direction. Therefore, there is no negative sign. Okay, so we get a total of 20 Newton. Okay, so now what about 1B? Izati, what is the resultant force for 1B?
40 newtons.
Okay, why do you get 40 Newton?
65 plus negative 25.
Okay, because the two forces are in opposite direction, therefore the resultant force, let's take 65 Newton, okay, plus 25 Newton. Okay, we have two opposite direction, so one of the force we must put negative sign to show that they are in opposite direction. Okay, so we get 40 Newton. Okay, very good. And then as for C Nurul Ain, what is the resultant force?
Negative 20 Newton.
Okay, negative 20 Newton. How do you get negative 20 Newton?
Negative 16 Newton plus bracket 15 plus 25 Newton.
Okay, so since there are three forces and two forces are in the same direction, whereas the other one is on the opposite, and since you decide to the left is negative, then we can write 60 Newton negative plus 25 plus 15. So we get negative 20 Newton. But if somebody answer 20 Newton, is it correct?
It's correct, but you need to write to the left. 20 Newton to the left.
Okay, so both are correct. It's just that we need to emphasize on the direction of the resultant force. Okay, so looking at the diagram, can you tell me to which direction is the acceleration of the object for 1A? 1A, Renisha, can you please tell me which direction will the object move with acceleration? Renisha Kaur. Or are you writing your answer in the chat? To the right. Okay. So, mana pergi tadi? So, A, the acceleration is to the right. Okay. So, based on the question, we can conclude that direction of acceleration will be based on the direction of the resultant force. It follows the direction. It follows the direction of the resultant force. Sorry. Okay. So for B, the direction is to which direction? Renuga. For 1B. Okay, two forces, 65 and 25. So to which direction is the acceleration? Renuga?
To the right side, teacher.
Okay, so for B is also to the right. So since we take right as positive, so our answer is positive. Therefore, we can say that the lorry will accelerate to the right. Okay, and as for 1C, which direction is the acceleration? Naomi. Naomi, so for 1C, which direction is the acceleration?
To the left, teacher.
Okay, so since,
To the left.
yes, so since 1A, the acceleration is to the right because the resultant force is 20 Newton positive. Same goes with B, 40 Newton positive. Both are moving to the right. And for C, the resultant force is negative 20 Newton. So it should be moving in the opposite direction as A and B, which is to the left. Okay, very good for all the answers. So let's look at question number 2. For question number 2, we can see two boys are pulling a cow with two forces. Okay, and if you look at the diagram, the two forces are exerted perpendicularly, which is 90 degrees to each other. Okay, one force is 60 Newton and the other force is 80 Newton. So how are we going to determine the direction and the and the resultant force for the cow? What method can we use? Wei-Wen.
Pythagoras theorem.
Sorry?
Pythagoras theorem.
Pythagoras theorem. Okay, or we can also use parallelogram. Okay, both are the same. Bukan the same lah. Actually, both method we can use. Okay, so since the forces are exerted 90 degree, so if we draw a parallelogram, we are going to draw two parallel line to another line that is parallel to the 60 Newton with the same length, with the same direction. And the other one, 80 Newton, another parallel line with the force 80 Newton, same length, same direction. Okay, and from here we get the distance. Okay, but since the diagram is 90 degree, we can use Pythagoras theorem. Okay, so by using Pythagoras theorem, can someone tell me, Kinisha, can you please tell me what is the resultant force of the two forces using Pythagoras theorem?
Is it 100?
Sorry?
Is it 100 Newton?
100 Newton. So how do we get 100 Newton? Kalpana.
Pythagoras theorem.
Yes. Can you please?
Square root 80
root?
square plus 60 square.
Okay. 80 square plus 60 square. So we get 100, isn't it?
Yes, sir.
Okay, so we get 100 Newton. So if you look at the parallelogram, so the resultant force is the hypotenuse of the triangle. Okay, so by using that, referring to the diagram, we can use Pythagoras theorem to calculate. Okay, so actually there are two methods. One is using drawing, the other one is using calculation. Okay, since both diagram are exerted 90 degree, which is perpendicular to each other, we can use Pythagoras theorem. Okay. Can you understand for the second question 2A? How we get the resultant force? Any question on this? Any response?
No.
Okay. Okay, semua faham eh? Okay, so now let's go to the next question, which is B. So Ashley, can you tell the class what is the resultant force for the boat? Okay, the boat exert or thrust have a thrust of 120 Newton and the water flow perpendicularly to the boat with 50 Newton force. So what is the resultant force? Terkejut What is the resultant force? Ashley?
1 minute.
Sorry?
1 minute, I'm looking for my answer.
Okay. We can calculate using Pythagoras theorem. Okay, the resultant force is the hypotenuse of the triangle.
Teacher, is the answer in decimal, teacher?
I'm not very sure. I don't know. I tak kira pun. What answer do you get?
Never, teacher. I calculated wrongly earlier. Is it 130
100?
and 30?
130. Okay, so let's look at the diagram again. Still, we can use two methods. One is drawing. Okay, we draw the 50 Newton. Okay, and then the other one is 120 Newton. So if we use parallelogram, we need to draw another line parallel to the 50 Newton. Okay, with the same length, with the same direction, so it is the same force. And the other one is line parallel to 120 Newton. So it is also the same force as 120 Newton here. So the resultant force is this one. Okay, and if you look at the diagram, we have two triangle perpendicularly to kita panggil apa triangle yang 90 degree ni? I lupa. Okay, so we can use Pythagoras theorem. So let's say this is x. So x square equals to 120 square plus 50 square. So x is root 120 square plus 50 square. So do we get 130? Dapat tak? Saya tak kira. Is it 130?
Yes, teacher.
Okay, very good. Okay, so this is how we calculate the resultant force if the forces are perpendicular to each other. We can use Pythagoras theorem, which is easier because this is calculation. But if you want to use parallelogram, which is a drawing, there are a few conditions that we need to follow. Okay, so let's look at this question, question C. For question C, it's very hard for us to calculate because we have two forces and the two forces is 40 degree to each other. So we cannot use Pythagoras theorem. Pythagoras theorem is only for a triangle that is 90 degree. Okay, so for this one, we need to use the method which I told you before. We call it as parallel. How to spell it? Parallelogram. Dia tolong check betul tak spelling I. Macam salah je. Parallel, is it double L? Okay, so this method is we draw a diagram. First, we must use a suitable scale for the force. Okay, we must use scale because we want to get the distance or the length of the resultant force. So let's say we take 100 Newton is to 1 cm as our scale. Okay, so the next step is we need to measure accurately for the force and also for the angle. Okay, so for this method, we need to use protractor. Kena ukur dia punya angle accurately. Okay, so if this type of question occur in your exam, you need to use ruler, you need to use protractor because you need to draw the force with suitable scale, one, and number two, the angle should be accurate. Otherwise, your answer won't be correct. Okay, so let's draw again the force. So this is 20 Newton. So if 20 Newton to 100 Newton to 1 cm and the force is 200 Newton, this force should be 2 cm. Okay, so we have draw the length of 2 cm and don't forget to draw the arrow that showed the direction. Okay, and then by using a protractor, you need to measure the angle here, 40 degree. Okay, so this one would be 5 cm because the force for the next boat is 500 Newton. Okay, so lepas tu, don't forget to draw the arrow. So ini kita dah belajar dalam vector at maths form 4 also. Okay, form 4 dah belajar ni vector. Dia lebih kurang sama. And as for 500 Newton, if we draw a line that is same direction, same length, it is also the same force. Okay, and then we draw another one parallel to the 2 cm. Okay, so lastly, to determine the resultant force, okay, how do we determine resultant force? So let's look at the arrow. Arrow to, this is the starting point of the arrow. Yang ini, I mark it with X. Okay, so since this is the starting point of the arrow, so we draw the line until, yang ni arrow satu tinggal. Okay, we draw, sorry. Okay, we draw a line from the starting arrow, yang ni arrow dia mula start for both, and then the point where the arrow meet, so this one. So this is the resultant force. Okay, so how do we determine the resultant force? What should we do next? Can Abirami tell us what should we do next after we draw the resultant force? Abi? Sorry? What should we do next? Yeah, Abi? Oh, your speaker, your mic is not very clear. Okay, can someone help Abi? Ashana, what should we do next after we draw the resultant force?
Teacher, is it we have to find the value of the green line?
Okay, so how do we find the value of the resultant force? From where?
Pythagoras theorem, we take out one triangle,
Mm-hmm.
and then the angle where the 2 cm and the 5 cm line is subtended is 90 degrees, and then the other side is 20 degrees. So we use so
This one is quite hard for us to do calculation because the 40 degree is for two different forces, two different value. One is 500, the other one is 200. So we don't know which angle, which force has bigger angle. Okay, so that is why we use parallelogram. Can you follow, Ashana?
yes, teacher.
Okay, so now we have drawn the two parallel, the parallelogram. We have drawn the parallelogram. So we have the green line as the resultant force. So what is the next step?
Calculate the length of the green line and then use the scale of the drawing that says that our scale is 1 cm equals to 100 Newton. So 6.7, which is my resultant force, times 100, so I get 670 Newton.
Okay, so after we draw the resultant force, which is the green line, we measure the green line. For this diagram, we no longer take into consideration the angle of the resultant force. Okay, for parallelogram, they won't ask you to which direction. If they ask you to which direction, you have to show in the diagram. Okay, you don't have to measure again the angle. Okay, what you need to measure is only the resultant force. Okay, if this type of question came out. Okay, so you don't have to worry about the angle anymore. What you need to determine now is the value of the resultant force. Okay, so we measure the length of the resultant force. Okay, like, is it Hui Wen just now?
Yes.
Okay, so like Hui Wen told us, her diagram is 6.7, isn't it?
Yes.
Okay, 6.7 cm. Okay, after she measured the resultant force, she gets 6.7 cm. So convert it back into the force according to the scale. So we get 670 Newton. Okay, so let's look at D.
Teacher,
Yes.
if I the calculation for C, right, I get different answer.
For C, it's very hard for us to calculate. Because if we want to do resolution of force, we need to know exactly what is the angle of each forces. So since now we have two different forces, one is 500, one is 200, and the angle of 40. So kita tak boleh simply draw a line in the middle. Okay, we cannot say 500 is for 20 degree horizontally and 200 is 20 degree horizontally. We cannot say like that because there are two different forces. If the forces are the same, for example, this one is 200, the other one is also 200, then we can draw a line in the middle and we can say that this one is 20, this one is also 20. Okay, but since C, the two forces are different, so the value of the angle are not equal. Okay, can you follow? So for this type of calculation, for this type of question, we cannot use calculation. So that is why you get different answer.
But if after I draw a parallelogram, so I get the other angle of the opposite side of 40 degree, because they say that if the angle of two sides is parallel,
Yes.
then the angle in the sum of these two angle is 180. So I take 180 minus 40, so I get 140. Then after that I use a square plus b square minus 2ab cos 140. Then this answer I go and square root it. I get 574 Newton, which is very different with the one that I use the drawing type.
Do you get 90? Do you get the angle 90 degree for any of the forces?
No.
Since since we did not get 90-degree angle, we cannot use Pythagoras theorem. Pythagoras theorem is solely for a 90-degree triangle.
But teacher, I'm not using the Pythagoras theorem. I'm using the trigonometry, the
You see
last,
the trigonometry method lah.
yeah.
Kalau guna trigonometry, you should get the same answer. Maybe drawing you is according to scale. You ambil 100 Newton to 1 cm, is it? Or are you using different scale?
I using same scale.
Okay, so you should get the same answer if you are using trigonometry. But for this chapter and for this subtopic, we don't use trigonometry as our problem solving. So kalau awak guna trigonometry in your answer, let's say for exam or for SPM, you might get the wrong answer kalau according to the scheme, marking scheme. So I think the best method is you follow this. We use the parallelogram. If we have two forces that is exerted onto an object at a certain angle. Okay, like for this question for C. Same goes for question D. Okay, for question D, we have two forces, 200 Newton, 250 Newton, and the two forces are exerted onto an object at 120 Newton. Okay, so if possible, we use parallelogram and Pythagoras theorem only for this resultant force. Okay, boleh?
Yes, sure.
Okay, so kalau it's good for us to use a different method. Okay, it shows that we can think divergently. However, there are certain safe way for us to answer. Okay, so for this one, we use parallelogram or we use trigonometry if we use Pythagoras theorem if the angle is 90 degree. And if the angle is not 90 degree to each other, then we use parallelogram. Okay, so let's look at D. For question D is also the same. We use scale. Okay, we choose a suitable scale. Okay, I can see the most suitable scale here is 100 Newton is to 1 cm. Okay, kalau nak lebih besar sikit drawing, 100 Newton is to 2 cm. Okay, the scale is up to us to determine. Maksudnya you tak perlu ada certain scale yang you have to follow. Because this is your answer, this is your drawing, you choose your own scale. Kalau rasa nak besar, then use bigger scale. The bigger your scale, maksudnya the bigger your drawing, the more accurate your answer is. Okay, tapi jangan besar sangatlah sebab dalam SPM you cuma ada A4 paper je kan. So agak-agak lah. Okay, so because if 100 Newton is to 1 cm, so ni jadi 2 cm, ni 2.5 cm. Agak pendek juga kan. So maybe we take 50 Newton is to 1 cm. Now we get a bigger diagram. Okay, so after we choose the suitable scale, we draw the parallel line with one force and another parallel line with the other force. Okay, and lastly, the line that connecting the initial position ataupun the starting point to the arrow yang mid. And then we measure. Okay, so that is how we calculate the resultant force if the forces are exerted onto an object at a certain angle. Okay, so far, can you follow the method on how to calculate or how to determine the resultant force for two parallel forces? Yes. Boleh?
So what is the answer?
Answer saya tak buat lagi. You dapat apa?
230 Newton.
230 Newton. What about the others? Do you get the same answer, 230? Are there any different answer? When answers is 230.
Is Mei Hui Chen.
Mei Hui. So what is the other the
225.
225? Okay, more or less the same. Ada jawapan lain yang sangat-sangat berbeza? Anybody get answer that is very different from this one, from this value? Yes, kita tengok dekat chat. Any other different answer? Tak ada. Okay, so if you use this method, you should get answer yang lebih kurang macam ni lah, 230, 225 or 235. Okay, sebab kalau kita guna diagram scale 1 cm is to 100 Newton, we get small diagram. Okay, it's best for us to choose smaller scale so we get bigger diagram. Okay, the bigger the diagram, the more accurate our answer is. Okay. Okay, so we have look into resultant force. Okay, the first resultant force that we discuss is forces that are parallel. Okay, parallel forces macam ni, like the question in 1A, B and C. Okay, and then we have forces that are perpendicular to each other. If we have forces exerted perpendicular to each other, we can use Pythagoras theorem, which is, for me, is much more easier rather than drawing the parallelogram. Sebab kalau nak buat parallelogram, you have to measure the angle accurately. Tapi 90 degree angle senang lah lukis. Okay, and also if we have a diagram of forces that is exerted onto an object at angle different than 90 degree. Okay, the best method to calculate the resultant force is by using parallelogram. And some book, they draw triangle. Sama je, triangle is without the parallelogram. It's without the apa yang segitiga empat tu. Dia ambil yang this part sahaja pun boleh juga. Okay. Tapi if we want to draw the triangle, dia punya arrow, katalah we draw this one parallel to 200 Newton, nak ambil yang triangle je. We don't want the segi empat yang parallel tu. So this is the starting point. This is where the arrow stop. So it's from here to here. Okay, so method dia lebih kurang sama. Instead of drawing a rectangle, we draw a triangle. Okay, so any question on this?
Teacher, for 2A to be what's the direction?
2A,
And
the
2B.
direction, 2B, sorry. 2B direction is this one. It's X, this direction.
If we want to do in word form, we should say to the right or upper right.
Kalau direction, this is north. Kan? Ini north kan? This one is north. This one is west, is it? Utara, timur, or this is east. So this one is called what? Kalau yang ini, kalau this one is north, east, ni apa nama dia? Timur laut. Now English apa? Saya pun tak pasti apa dia panggil. Okay, if the question asks us to write the direction, okay, kita nyatakan is we cannot say that it move to the right because it's not to the right. Dia atas sikit kan, dia buat angle kan, macam arah timur laut. So what do you call this one? North, east, so it's here.
This one,
The
angle,
the direction.
the northeast.
Northeast yang nama dia.
Northeast.
Okay, so the direction is to the northeast. Northeast direction. Okay. If we show using Pythagoras theorem for the answer, and we need to state the direction, so the direction is northeast. So kalau yang ini, this one is also northeast juga. Tapi kalau the direction is like this, tu kena tengok direction lah. Macam tengok kompas kan. But usually, if this question came out, they never ask direction. They only ask the value of the resultant force. Okay, because they know that you are going to calculation. Yes.
If they ask the angle of the direction, how do we calculate it?
Dia takkan tanya angle of apa resultant force. If the question asks us to determine the angle, then measure the angle, use protractor lah. If we draw using diagram. If not, the direction is northeast. Itu sahaja. Okay, so you don't have to worry. They will never ask us the angle for this one. Dia takkan tanya punya. It's not up to your level yet. Nanti bila naik ke yang lebih tinggi, you are going to learn more about this. Okay, so any question? Any more question? Yang lain tu senyap je?
No, Teacher.
Okay, so since there are no more question on the resultant force,
Teacher,
yes.
someone asked, must we paste this exercise in exercise book?
Yes. Print it out and paste in your exercise book. Oh, for 5E, what book do you use? How many books do you use? 5E. Can I get a response from 5E student?
They say one small book.
Okay, one small book. Okay, so you continue using your book from the Form 4 physics. Okay, you are allowed to continue using your book from last year. Jangan waste beli yang baru. Because you are going to use that book as your revision kan. So might as well use it, continue using it. Okay, so my method is when I give exercise, you need to paste in your book and write the answer in the book. Okay, boleh? Any more question?
Teacher, if the work is submitted through Google Classroom, we still need to print out.
Okay, so for those who have submitted in the Google Classroom, you don't have to print out. You don't have to do work twice lah. Sebab lebih kurang je. Okay, I can check in your Google Classroom, but for your exercise book, it's for you to do revision easier. Sebab kalau you nak check back in the Google Classroom, maybe susah sikit. Okay, so for the exercise book, the physical book is for your own use. Tapi kalau you hantar dekat Google Classroom, I will mark.
Okay, sure.
Okay. So, we have looked into resultant force for parallel forces and also for forces that are not parallel. Okay, so now let's look at a resultant force on an object in a various states of motion. When we have an object, okay, either the object is at rest or the object is moving. When the object is moving, either is moving in constant velocity or acceleration. To determine forces that acted on the object, we draw what we call as a free body diagram. Okay, the free body diagram is a diagram that shows all the forces acting on the object. Okay, we have discussed this earlier. Let's say we have an object that is stationary on a table. Okay, like this one. Okay, we have also discussed the forces. Okay, you already told me that there are two forces. One force is downward and one force is downward. The other force is upward. Okay, and you also have tell me the name of the forces. Okay, we have weight, and also for the force upward due to the surface is called normal reaction. Okay, so for normal reaction is only the force exerted from a surface to an object. Okay, if you look here, it's normal reaction from a table. Okay, and the surface will exert the force perpendicularly to the object. Okay, and then we have this one, the diagram. The next diagram, we have a trailer, and the trailer is moving to the right. So since the trailer is on the ground, there are two vertical forces. One is the weight, one is the normal reaction. And since the trailer is moving to the right, there should be two forces or one force horizontally. Okay, in this case, there are two forces, which is the pulling force, and the opposite force is frictional force. The next one is a rocket. Okay, the rocket is moving upward. The direction is upward. So there are two forces. One is the weight of the rocket. The other one is the engine thrust. And we have one more force, which is the air resistance. And air resistance friction is always opposite direction of motion. Okay. Sekejap, ambil attendance. Saya terlupa. Before I forgot. Okay. And we have one more, which is an object which is placed on an inclined plane. Yang ini a bit complicated because the plane or the surface is at an angle, is inclined. Sebab if you look at this diagram, and this diagram, the three diagrams are all on either horizontally or vertically. But if it is on an inclined plane, dia tak horizontal, dia tak vertical, dia at a certain angle. Okay. So this one we have also discussed in our previous class. Okay, if an object in a stationary state, all the forces that is acted onto the object are equal and opposite direction. So sama macam this situation lah. Dia tak bergerak, stationary, so only two forces, upward and downward. And this one, the object is moving in uniform velocity. So upward and downward motion, forces is equal. And then horizontal forces, opposite direction, must also be equal. Sebab The clue is it's moving in uniform velocity. Uniform velocity acceleration is 0. Okay, and then we have the last diagram, which is a car, but the car is now moving in uniform acceleration. And remember, Newton's second law said that when we have a force or resultant force exerted onto an object, the object that have a mass will accelerate. Okay, from there, he produced a formula which is F equals to ma. Okay, so if you need explanation about certain concept, you can refer to the formula, because from the formula is also explaining that concept. Okay, for example, this one, the Newton's second law, F equals to ma. When there is force, object that has mass will accelerate. Okay, so if the A is 0, so there is no force lah. So that is how you can remember lah, if you need to know what is the resultant force. Okay, so let's look at this one. This one is from your textbook. Discuss the resultant force that act on an object with the aid of free body diagram. Okay, we have stationary on the ground. We have a drone. Okay, the first diagram, stationary on the ground, engine is switched off. And then we have the second diagram, move upward with acceleration, and we have move upward with constant velocity. So please refer to the diagram, and when I call your name, please state what is the acceleration, what is the resultant force, and comparison between the forces. Kavya, can you please state the situation for the first diagram? This is the first diagram, this is the second diagram, this is the third diagram. Kavya. Yes, Kavya? Can you switch on your mic? If you cannot switch on your mic, can you please write your answer in the chat area? Kat chat pun saya boleh tengok. Okay, if you switch on your mic, you boleh terus cakap lah your answer. Yes, Kavya? Still waiting for Kavya. Okay, so let's call upon Abhirami Tiaga. Oh, there are two Abhirami now. Abhirami Tiaga, can you please state the situation on diagram 1? Yes? Any respond? Ke mic speaker ada problem?
Teacher, my internet has problem, teacher.
Who is this? Siapa ni? Dengar suara kecil je. Okay, so let's call upon Idina. If you cannot, yeah.
The acceleration is 0.
Okay, for the first diagram, acceleration is 0. Resultant force?
0 as well.
Okay, and the forces? Comparison between forces.
I'm not sure, Chair.
Okay, so who can help Edina for the comparison between forces?
Is it 0? Is it comparison resultant force?
No. A comparison between forces, you need to tell me how many forces, which direction, and the relationship of the forces. So based on here, there are two forces. So what is the relationship between the two forces?
Teacher, there's normal force and weight.
Okay, and the weight, what are the relationship?
Both are equal.
Okay, so comparison between forces, we have two forces that are equal and please add two forces that are equal and can someone continue? Archana?
And what?
And what? Two forces that are equal and how do we get resultant force 0?
Same.
Can, yeah, the two forces are equal, are the same, but what is different?
Opposite direction.
Sorry?
Magnitude.
Magnitude is the same.
The opposite direction.
Opposite direction. Opposite direction. Okay, so this is how we write comparison between forces. Two forces that are equal and opposite direction. Okay, so let's look at question diagram 2. For diagram 2, just Jessamine call. Can you please tell me, are there any value for acceleration, or is the acceleration 0? Jessamine call. If you have problem with your speaker, you can write your answer in the chat. Tak ada. Kalpana. Diagram 2. Yes, Kalpana?
Sure.
Yes.
Jasmine typed the answer in the chat, sure.
Oh, okay. So there is a value of acceleration. Okay, so we have a value for acceleration. We don't know what is the value, but there is a value. What about the resultant force? Kalpana? Are there any value or the resultant force is 0?
There is a value.
Okay, so for the resultant force, there is a value also. And what about the forces on the drone? Siapa? Mei Hui. Comparison between forces for the second diagram. Mei Hui?
Is it normal force is more than weight?
Okay, normal force is more than weight. When there is no surface, we did not call it normal force anymore. This is called lifting. Kan dah bagi tahu last week? Okay, so lifting force is more than weight. Or you can simply say that the upward force is bigger than the downward force. Okay, so for the third diagram, Sutashini. Sutashini, what about the acceleration, resultant force for the third diagram? Okay, 0 acceleration. And then what about the forces? The resultant force, 0. Resultant force. Resultant force equal. Resultant force. Is the resultant force equal? Resultant force is when you add all the forces together. Kalau yang opposite direction, you put negative sign. If the direction is the same, there is no negative sign. So what is the resultant force? There's a value. Okay, so are there any value for resultant force? Everybody, do you agree? If I say that there is a value for resultant force. Yes, who said that just now? Are there any value? Yeah, we went.
Isn't it constant velocity if we substitute the 0 into the Newton's second law F equals to ma? Resultant force is still 0.
Okay.
Due to
Here, the resultant force is 0. Why the resultant force is 0? Because it is moving at constant velocity. If you refer back to the Newton's second law, F equals to ma. So since A is 0, A is 0 times m, F will equal to 0. Therefore, the resultant force is 0. And lastly, comparison between forces. Tejasin. Comparison between forces. Tejasin. So what is a comparison? If there are two forces on the drone, okay, like this one, lifting and weight. So what are the relationship between lifting force and weight? Tejasin. Okay, we have here. Last one, comparison between forces. Tejasin. Can you write your answer in the chat area or you can switch on your mic? Yes. Can Yoshini help Tejasin? Yoshini. Okay, Tejasin not sure. Can Yoshini help Tejasin for the answer for the second for the comparison between forces? Okay, so since it is not on the surface anymore, so there are two forces. One is lifting, which is upward. The other one is the weight, which is downward. So what is the relationship between these two forces? Is it equal or is one bigger than the other? Lifting force
is equals to the weight.
Yes. Okay. So lifting force is equal to the weight. Lifting equal to weight. Okay. So we stop here. It's 10 o'clock now. But what I want you to do is I want you to, example ni ada answer. Never mind, I'll give you another exercise for resultant force. Okay, yang itu nanti you kena submit lah and paste in your book. Okay, for the next class, we are going to discuss problem solving involving resultant force, mass and acceleration of an object. Okay, so we stop here. So thank you very much class for staying.
Sure.
Okay.
Thank you, Sir.
Thank you, Teacher.
Thank you, Teacher.
Thank you, teacher.
Okay.